All right, we're a minute in, so we should probably get started. I guess first, Rob, do you want to talk about uh, the 15526 and all of that and just provide an update?
Yeah, I'll try and keep it short. So there a so what was it 1.15226? A bug was reported that a build system of some sort that was compiling a Go program was turning up zeros in the target file. And because this happened so close after the 2.2 release, uh, block cloning was the guess. And then Tony produced a a reproduction script, which very quickly showed that it also happened on 2.1. And so we all went, huh. And so a whole bunch of people over the Thanksgiving weekend dived into that and discovered basically a sort of a mischeck in the code that does hole detection. So when you call lseek hole or lseek data, you can get the wrong answer in a very, if you manage to hit a very small gap where the D node appears clean when it hasn't yet been synced out to disk. So that's the summary. We scrambled a fix in, which is it's a solid fix. It's not the correct theoretical kind of fix, but um it seems good. And then that went out. There was new OpenZFS releases 2.2.2 and 2.1.14, and FreeBSD 14, 13, and 12. All the supported versions received a patch for that. I think Illumos have just the last couple of days have landed a patch for that. And it looks like it's a very old bug. It's been reproduced back to OpenZFS 0.6.5 at least, and I'm not sure if anyone's gone earlier than that, but yeah, as I say, it was in Illumos. And there's some evidence to suggest it was there since the beginning. So I'm not saying it is there since the beginning. No one's tested back that fast. There are some people trying to get old Solaris 10 images and try and get those up and running and get some tests going. So I'm more than happy for them to do that. So yeah, so it was kind of an annoying bug. The good thing is it required a lot of different moving parts to meet in just the right place. So I think I feel I've been telling people that I feel reasonably certain that like casual undetected corruption is highly unlikely. Um, it's a difficult message to get through, um, but I do think that's true. Um,
Right, because
and
it mostly required basically copying a file and using hole detection during the copy and that getting it wrong and choosing not to copy a chunk of the file.
Yes, and but also only after it had been very recently dirtied and you had to hit a very tiny hole, and then you had to not actually look at the file that you that's to hit it, but then you had to not actually look at the file to for it to be undetected, and those are a pretty rare combination of events, I think. As best we can tell, zvols are not implicated. Send and receives are not implicated. There's no way for them to touch those code paths. So it's kind of we dodged a little bit perhaps, but old bugs, good fun, and it has there are people working on uh like trying to get tests for this into the test suite, and it's there's been some positive. I've had some positive sort of signs of people trying to get involved. Oh, let's get the XFS test running again. Let's get a few other bits and pieces running again. So, if it leads to some improvements in testing and a few more eyes on the code, I will not be sad. I'll count it as a very soft success. Uh, I think that's all I've got. Um,
Yep.
there's a lot more detail, but I can write that for anyone anytime. That's on the list that's in the GitHub. So whatever you like.
Yeah, and I think part of the reason it seemed to surface as part of 2.2 is just corresponding update in core utils to default to trying to do hold detection.
I I think so. I know early some people got some success by turning off block cloning. They seem to work around it, but I haven't actually seen anyone definitely show that block cloning is involved, and I can't really account for it outside of, vague timing differences. So that's my best guess is, yeah, because it was Core Utils 9.2, which is relatively recent as far as distributions go. So
Okay. Did anybody have any questions before we move on?
Yeah, I guess, and tell me if this is out of scope for this meeting, but I, is there a plan to patch back to the 0.83 release to go back that far? Because that's Ubuntu long-term support 2004. So just wondering about that and whether that's something we can expect in the community.
I can do a patch pretty easily. It's pretty much the same patch. It just slides right over the top. That I don't know that there would be a release. I would suspect not, but I'm not the one who does that. But yeah, look,
I
I'll
guess,
make a patch and chuck it up. It'll won't take long.
because I think even if there was a patch, it'd be, 0.8.n+1, but Ubuntu would then be able to pull that back into their uh, repos and ship the update there.
Yep.
Yeah, I don't have insight into how that whole process happens and how what we would need to do to make it something that Ubuntu would want to do. So yeah. Thank
Well,
you.
well,
Yeah,
I
it's I think mostly pressuring Ubuntu to take the patch once we generate it.
well, I'll make a patch and I'll post it on Ubuntu's tracker. And if they, I don't know what happens after that, but at least it's there. That's and if you think of more I could be doing, give me a yell. I'm happy to.
Yeah, I can think of a number of people that'll be happy to see that land in 2004. Anyone else? Okay, next thing on the agenda is the slow disk diagnosis with Z, pull request 15469. Don's done some updates there, and I think has solved the problem with the last CentOS test. It has improved logic now so that if there's already a slow case outstanding, it won't trigger a second one. That's to kind of meet what Alexander Boughton asked for, of making sure that multiple slow disks doesn't trigger spare replacement a whole bunch of times. So if we've done one and that case hasn't been resolved yet, then we won't start a second one. But if people could cast their eyes over that pull request again for us, I think it'd be pretty much ready to go. And that extends the work we already did with the VDEV properties to allow you to control how many slow IOs and what period of time triggers automatically replacing the disk with a spare. Next up was the bio page splitting. I think, Rod, you had an update on that as well?
Um, not nothing that's not on the
Pull
PR.
request, yeah.
I yeah, I just did some testing on ARM on 64K memory pages on NVMe drives up to like 8K logical block size, which from my code read I thought was not Linux didn't support, but it was only that it's supported in SCSI. Anyway, it all appears to work for whatever value of. As in I couldn't cause anything that wasn't just, the data is on the disk and the scrub is clean. Um, I couldn't cause anything else to happen. So no, I've got to do another run over that code just to make sure it's the comments match up, and I haven't got my math wrong anywhere else, but I actually think that's kind of good to go.
And you said you were seeing a performance increase even with sync writes?
Yeah, like modest with sync writes, about 1.3x.
Well, 30% is a little more than modest for sync writes, I think.
Yeah, I guess it was based on what I was looking at, because async writes was in my sort of, yes, I wasn't testing for performance, so there's a lot of variables and it's not very scientific, but like 2.7x on a workload that I run all the time. It's just it's 100 threads writing files between 1 and 16 meg, just open write close, for 10 minutes, and then just measuring the throughput. And yeah, when I turned off fsync on that, yeah, I get about 2.7x throughput. It bumped on a 12 wide Z3. It goes from about 280 megabytes per second. It's pushing 600 megabytes per second, which is quite surprised me because this was not a performance related patch, but the previous code would, when the Linux bio objects have a limit on the number of individual page pointers that you can put into it, and what we would do is we would get the math wrong and then vastly overestimate how many we could fit in there, and then once we'd filled it, we'd notice that we had no room, so we'd throw all our work away, reallocate with twice the size, and then go again. And also we were filling it with very, very small pieces when we could have filled it with much bigger ones. So that's kind of all I can account for, is like we're doing a lot less work, and then maybe we're presenting it in a much nicer form to the kernel. But I could measure it, but like I say, it wasn't there. So that'd be a nice side effect. But I'm still more interested in it not being able to screw things up when the input gets weird. So yeah,
Yeah,
weird.
because we'd seen in the field 4K native drives rejecting writes because they weren't aligned.
Yeah,
And that's why we started looking at this in the first place.
yeah, and it passes all those tests too. I've not been able to break it with everything we've tried in the last many months. So I feel good about it. It's kind of weird to me that there might have been that much performance sitting on the table for that many years, but but sometimes it goes that way.
That might
It's good.
mostly have to do with large record size. Like normally none of them would have been quite that big, possibly.
Possibly, I can't remember. Yeah, you need large record sizes. You need to get like big aggregation into play. So yeah, so possibly. Yeah, it's quite neat. So
It looks like we lost Pavel, but Pavel has a new pull request open to connect more block cloning tests. So obviously it'd be good if people could take a look at that. I think he said in aggregate there's over 2,500 tests, and so the test suite will pick a random set of, I think, 100 out of those to run, so it won't add more than 10 minutes to the test suite each run, because otherwise all of those tests would slow down every CI run, and we don't want to do that. Mav, was there anything you wanted to talk about? I saw you had a couple of pull requests open.
No, yeah, last couple of weeks I was investigating block cloning from different perspectives, primarily from Zeal. Apparently that area wasn't well tested, and there was a number of fixes. Most of them are merged now, but I just created one more PR just 10 minutes ago. There appear to be a problem with writing maximum sizes TX block clone range records into Zeal when combined with early optimization of Zeal trying to split bigger blocks into a couple smaller ones. It caused buffer overflow and crash. No, easy assertion if kernel built with debug. So just to make a quick and easy fix, I just removed that optimization. I don't like removing optimization, but it's really the only trivial way that could be merged at any time, anywhere, if somebody needs it. While for longer term fix, I resurrected my older patch to implement next block size prediction. I need to improve it in Zeal. It was hanging around since summer probably or about. I partially upstreamed all the pieces, but there was last piece that actually also fixes the same problem, but just from different perspective. So I'd like people to take a look on both. Obviously, the first practically one-liner, two-liner fix. There's just not much to review, but the other one that should also not lose performance and hopefully improve together with space efficiency. I would like people to take a look. Just I got tired of things and hanging in drafts forever, and there was a good chance to make it and give it another life. So I'd like people to take a look.
Yeah, it's good to get all the stuff shaken out of our local trees, eh?
Yeah. Also looking on block cloning, I was able to hit some. No, there's already opened draft PR to fix assertion in case of cloning versus writing versus streaming case. And there's definitely some issue with state transitions. And I was able to reproduce it on my FreeBSD, but I haven't had a chance to look closer what does it mean. But so far, it's the last piece on my plate. I need to look of issues of block cloning I know about. So I'm going to take a look on that nearest days. Now with that Zeal fixed. At least I'm not aware about anything else. If anybody know about any other issues, please let me know. I'd like to hear.
Yeah, that's it. Hopefully we'll jive well with the test that Pavel is adding. He was here a few minutes ago. I don't know. He must have had to drop out. Were there other topics anybody want to talk about? Christian, was there anything you wanted to say?
Yeah, so mostly joined out of curiosity. I've been out of working full time on ZFS for a year now, but I am currently looking into the overlay 2 support and found a small performance issue. I created an issue on GitHub. I think it is it's super frustrating because this is kind of the last piece to make Docker just work on ZFS, and I think it would be nice to solve that. So I think there are a bunch of parties here that might have commercial interest in supporting smooth Docker experience. So if anyone wants to take a look at that, just filter by author my username, and then you'll find
It's
it.
15581.
Yeah, pretty sure.
I put it in the notes.
Thanks.
Another interesting thing we've been looking at this week is long file names. So file names longer than 255 bytes. And what it would take for ZFS to support that. Right now, at compile time, it's defined that the maximum length of a key for a zap, which is how directories are implemented, is 256 bytes. From a very cursory looks, it doesn't seem like it'd be impossible to have that key be longer. And so we might be able to do something like a per dataset feature flag that knows, if this, at creation time of a dataset, you can say, long file names enabled or whatever, and it would allocate all the zaps in that dataset with the longer maximum key size. I guess 1024 is pretty common for name max. But is anyone aware of other issues you might hit in ZFS from letting a file name be that long? Beyond just the fact that the zap where we implement the directory doesn't like a key to be that long?
Just recently, I looked on some code. I found there are two different constant for a name, which both set to 255 bytes, but with different perspective. I tried in one place. I forgot what it was. Just recently, a couple of weeks ago, was PR. I fixed one of cases, but I wonder whether we are consistent in all the places. Plus, in some cases, I remember it was allocated on stack. If we grow, we need to check that we don't overflow stack anywhere. Maybe we would need to move it somewhere to allocatable memory.
Yeah. Because the other related thing is I noticed that different platforms have a different path max. I think FreeBSD's path max is still 1024, but Linux is up to 4096 now. So that's the length of the entire path, including, you know, all the directories in the file name. And what is ZFS to do in that case, where different platforms have different maximums, and how to make sure that, you know, if you can create the file on Linux and export the pool and import it on FreeBSD, how do you make sure that you can still access the file? You know, even if we were to bump pathmax on the next release of FreeBSD, we still support older versions as well. So what is the right thing to do in that case?
Yeah, it's just written in the chat. It sounds like MS-DOS 6x style mangling, and it actually kind of is. Yeah, once you've got to have like a lowest common denominator kind of, you know, lossy format, you have to end up, yeah, like keeping a couple of forms or something like that. But I do know there's still some issues with like Unicode case normalization. I think I don't know specifics on that, but I know there's some disabled tests about it, and I think the Jorgen working on the Mac OS port or the Windows port.
Both.
One of the
Same guy.
both. But yeah, same guy. But one of them, he was looking at something with you can change from in case sensitive to case insensitive on a particular directory. There's some options. So you end up having like you have kind of a display form and a normalized form, and it was like how to put that together. And I don't know if he got anywhere with it, but there's sort of, to me, it feels like there's enough shapes flying around of what is a file's apparent name versus what is its sort of interoperable name, if you like, that there might be a bit of might be an opportunity for a bit of a rethink around a few shapes of problems to be able to support a few different things. But you know, it's a scope thing. But there's some interesting stuff in there. Unicode's
Yeah, I know
fascinating.
Jorgen had also talked about trying to do long file name support with extended attributes. And so maybe you use a truncated version of the name along with the ZAP's collision discriminator. So that, you know, a bunch of file names that all start with the same 255 bytes but are different after. We would only use, what is it? Normally in the ZAP, it uses the 48.
Oh yeah.
Something for the discriminator.
Yeah, 48 bits of hash and 16 bits of 8 bits of the other thing. So
Yeah,
I'm just
like
completely math wrong in public. But anyway, but yes,
yeah,
you're right.
So something like that where you would still be able to have the ZAP be backwards compatible by only having up to 255 bytes of the file name, but with a discriminator so that, you know, 3 files that were all different names but after the truncation mark would all be able to be in the ZAP, and then have extended attributes that contain the longer name, and that might be more backwards compatible than having to do a feature flag. But I don't know, you know, the performance cost of having to read the extended attribute, especially if it's going to, you know, be up to a kilobyte for every file when you're listing a directory, might make it pretty unfun. I suppose if you're using larger dnodes, then maybe you make sure that that extended attribute stays in the dnode, not into a spill block. But
yeah,
in the end, I think you want to make noise, like on the old system. Like if you make it so that the old system can import the pool, like I don't know if it's a good behavior to just do it silently.
have a bunch of kind of truncated names, and
yeah. like it always risks that like someone, I don't know, imports a drive on an imports a pool on another version of CFS, then uses rsync or something to bulk copy the data away and think everything is right because they never got any errors, but then they do. This could look like data corruption.
Yeah.
It's something we don't want.
For sure. So yeah, doing a feature flag is probably definitely the right way to go either way, so that we can block all unsupported. But which way around to implement this so that it'll work across platforms, and possibly with the fact that different platforms will implement different limits on the maximum length of a path name, and how to kind of deal with that. And like Rob said, it probably brings back some of the importance of some of the collation stuff, or just how you sort these really long names that are maybe full of Unicode characters. Because, you know, everybody wants to name their files with lots and lots of emojis in them, right?
I have one other subject, cycling back to the overlay tools, OverlayFS support. So I asked about this in the OpenZFS like a couple of weeks ago, but never got an answer. So basically, I don't think anyone has really thought through the ZFS send receive implications of the whiteout support. So like as a summary, whiteouts are for like a special flag that we store, I guess, in the set underscore thing in that struct. Basically, you remember for a given inode that this is a placeholder for we deleted the file. An overlay needs this to support deletions. Like what happens if we send these to another system?
Right, because on Linux, those are implemented by making a device file that has a certain ID number, I think 0 or something.
A device file?
Yeah.
Okay. Yeah.
Because I know like in UFS, it's a new type, like directory file, etc. And I looked at what it would take to do that in ZFS, but that would actually be incrementing the ZFS file system version number, which is still 5. We didn't change it or come up with feature flags for it. But it turned out on Linux, they dealt with this problem by basically making a device file like you would have in /dev on the file system to note a whiteout. And I think maybe it's just major minor 00 or something that implements that. But yeah, it's a good question about how that survives send receive, but especially when it comes over to FreeBSD, where it doesn't have the same convention about that meaning a whiteout.
Yeah, so that is what I was concerned about. I'm not concerned about send receive itself because that happens at a lower layer, but the interpretation of these bits. And I wasn't aware that we are using a device inode type, but still there's somewhere there's a bit mask that contains this whiteout flag, and it's possibly interpreted differently on FreeBSD right now than it is on Linux. And yeah, I don't think we have any tests for that, or this was even part of the design. Yeah, that is relevant for zREPL because I'm afraid of people running into that at some point in the future.
Yeah, and that maybe we can just even do some platform-specific code to notice the device file or whatever like you said, the bitmask in the dnode is, and make sure that each operating system implements it in the right way for that operating system, so that whiteouts will stay whited out and don't make a weird file you can't play with, or causing the file from the underlying file system to show through.
Does FreeBSD have an equivalent for overlay? There's UnionFS, but I don't know if it does whiteouts. Does it?
I think so. And I know UFS has support for whiteouts, so that when you use it with UnionFS, it can persist them. But
I think they just represent it in different way. There are special type of file or something.
Yeah, on UFS they're a special type of file, whereas on Linux they're a device file with a certain major and minor number that means this is a whiteout. And it might be that just in the FreeBSD compat code we need to implement a check to expose to VFS that this weird combination means a whiteout, so that they show up as whiteouts on FreeBSD properly.
If that's all there is, then that's okay. But yeah, I don't have time to look into the implications of this, but I wanted to make sure people are aware. Okay, thanks.
Were there any other topics people wanted to go over? As Mav, the ZIL prediction item you added is the one you already talked about, the predicting the next block size?
Yeah.
Okay.
Just wanted to give a reference.
Yep. Thank you very much. Were there any other items or questions? I suppose we can wrap up early then. Thanks everyone for coming, and thanks to Rob and everyone who worked over the long weekend to get a fix out for the seek-hole problem.
Thanks. Yeah, good bunch of people popped up. Very happy. It's good fun.